Inverse operations. In mathematics, we refer to operations as being inverse operations of each other when they undo each other. Addition and subtraction are inverses of each other because, you know, 3 plus 4 equals 7. But if you take the 7 and subtract 4 from it, you get 3. So adding 4 to 3 gives you 7, but subtracting 4 from 7 gives you the 3 back. So this is what I mean by an inverse operation. Multiplication and division are inverses of each other. If I take 3 times 4, it gives me 12. But then if I turn around and take that 12 and divide it by 4, it takes me back to 3. Powers and roots are also inverse operations of each other. For example, x squared and the square root of x would undo each other. If I take 5 and square it, it gives me 25. But if I then turn around and take the square root of 25, I go back to my 5. Inverse operations undo each other. We're going to be looking at how to undo combinations of inverse operations. So let's look at this statement. Add 4, then divide by 3. Think about this as wrapping and unwrapping a box, a present. If in the process of wrapping a present, you add 4 as one step, and your next step in wrapping that present is dividing by 3, and then you take about unwrapping the present, the first part that you would unwrap would be the last part that you did. So the first step in the unwrapping is to unwrap the division by 3. So the inverse operation for division by 3 would be multiply by 3. Then you would undo the adding 4 as your second step. So to undo adding 4, you would subtract 4. So I described this verbally. Now I'm going to write the original statement symbolically. So that means you start with something, let's say x, you add 4 to it, then you divide that total by 3. I also could have written it like this, x plus 4 divided by 3. Write the inverse statement symbolically means you would start with your x, you would multiply it by 3, and then you would subtract your 4.